All right, here's the review video for your limits quiz, or your limits chapter test, actually. All right, so number one says, consider the graph of f of x shown below and state whether or not it is continuous at x equals 2. Well, so we go to x equals 2, which is right here. And if we follow it up, we notice that we have this big gap right here. Since we have that big gap right there, this is not continuous. All right, it is not continuous at x equals 2. All right, so because we got this gap right here, and if you remember back to the videos, when you have gaps, jumps, holes, anything like that, it is not continuous. All right. Number two, consider the equation f of x defined below. Is f of x continuous at x equals 1? So what you got to do here is you got to take the 1 and you got to substitute it in to both equations, solve, and see if they equal the same thing. So the top would be negative 2 times 1 minus 4, which is negative 2 minus 4, which is negative 6. And you plug in the 1, you get 1 squared minus 9. 1 squared is 1 minus 9 is negative 8. Since these are not the same, this graph is not continuous, or this function is not continuous. Oops. At x equals 1. All right, because they don't equal the same thing. The only way they're continuous is if they equal the same thing. All right. Come on. Move up, though. All right, let's move on to number 3. I'll delete the ink in just a second. All right, let's look at number 3. It says, consider the equation below. The value of w is constant, is currently unknown. If it is known that f of x is continuous, what must the value of w be? Well, what we're going to have to do is we know if this were to be continuous at 1, we would evaluate at 1 and see if they equal each other. So we're still going to evaluate this at 1. So let's go ahead and do that first because we're still going to evaluate it. So this will be 3 times 1 plus 4, which is 3 times 1 is 3 plus 4 is 7. And then this would be w times 1 squared minus 3. So 1 squared is 1, so this is simply w minus 3. All right, now, if these were equal to each other, we know that the function would be continuous. Well, we want to know what the value of w must be if we know f of x is continuous. So what we're going to do is set these equal to each other. 7 equals w minus 3, and we're simply going to solve for w. So add 3 to both sides. So w equals 10. All right, only if w equals 10 do both the top and the bottom function here equal each other. All right, quick way to see if that works. 10x squared minus 3. Well, x squared is, x is 1, so x squared is 1, so this is just 10 minus 3, which is 7. 7 equals 7, so we're good. So the answer w is 10 for them to be continuous at x equals 1. All right, moving right along. Let's go to number 4. All right, consider the graph shown below of f of x. Find the limit of f of x as x approaches 1, and it's a little plus sign, so that means from the right. All right, so we're coming from the right, so we're coming from this direction. So we're going along the graph, going along the graph. Up here's x equals 1. What is our y value at that point? Negative 4. So the limit of f of x as x approaches 1 from the right equals negative 4. Because remember, you use your y value to get the limit of your function. All right, you get the y, you use the y value to get the limit of your function. All right, so now let's find the limit of 1 over x minus 3 squared as x approaches 3. So if we use direct substitution, we get 1 over 0, which doesn't tell us much. All right, doesn't tell us much. So what we're going to need to do is make a table, because remember, at 1 over 0, this may be infinity. So what we're going to have to do is we're going to have to make a table, and we're going to have to use values of x that get increasingly closer to 3 from both sides to verify that the function does indeed approach the same value from both sides. All right. So you're going to have to get out your calculator for this problem, because we're going to have to use some pretty long decimal numbers. So let's start by making our table. We have x and we have f of x. All right. All right, so we know at x equals 3, the function doesn't work, so we're going to kind of ignore the 3. So we're going to get we're going to get really, really close as we come to here. So this will be 3.001, 3.01, and then the last one is going to be 3.1. And of course, going this way, we're going to use 2.999, 2.99, and 2.9. All right. So let's go ahead and start plugging these in. I'm going to start with the 2.999. So 1 divided by 2.999 minus 3, that squared gives us 1,000,000. All right, so now let's do 2.999. 2.99. That gives us 10,000. And then let's just do 2.9, which gives us 100. So what this looks like it's doing from the left side when we get to x equals 3. I'm just going to arbitrarily draw it right there. It looks like it is coming to 3 and then going up to positive infinity. So the limit from this side we're going to call positive infinity. As soon as this decides to write again. All right, there we go, positive infinity. Now let's attack it from the other side. 1 divided by 3.001 minus 3, that quantity squared. This gives us 1,000,000. And then take out one of the zeros and see what happens. 10,000. And then take out the last 0 and let's see what happens as well. 100. So as you can see, this is also doing the same thing. As it comes to 3, it takes off up toward infinity. So since this side, the left goes to infinity, the right goes to infinity. So our limit is in fact infinity. All right, our limit is infinity. So remember, when you get to 1 over 0, it's possible that it might be infinity, but you still have to check it out by making a table just to verify that they do in fact both go to infinity. Because say this had been negative 1,000,000, negative 10,000, and negative 100. If that was the case, this limit would not exist, because then the right side would be doing that instead of going straight up. All right, so make sure if you get to 1 over 0, it may be infinity. Make your table to verify that it is in fact infinity. All right. Let's scroll this down a little bit for 5 and 6. Find the following limit. The limit of this as x goes to positive infinity. Well, as you know, this and this are pretty relatively useless. The x squared and the x squared cancel out because when you throw the infinities in there, it'll be infinity squared over infinity squared. All that cancels out, leaving us with 2 over negative 2, which is negative 1. So our limit of this function, can't read it now because I crossed half of it out, as x goes to infinity is negative 1 because everything pretty much cancel out. So that makes that pretty simple. All right, now we got to look at this one. Now, keep in mind, this one's written in reverse order here. All right, so if you want, you can change it around, do 4x plus 5 over negative 2x plus 3 to make it a little easier. These cancel out. This cancels out. So you have 4 over negative 2, which is just negative 2. All right, makes sense? Just substitute it in. Well, infinity acts like a variable, so what you can do is you can actually go through the problem crossing out the useless information on the end, like this and this positive 5 are useless. The reason I rewrote it this way is so you don't actually accidentally cross out the negative and then say, oh, it's 2x over 4x, the x's cancel, so the answer is 2. That's why I went ahead and rewrote it this way, so when you cross this out, you still have your negative sign, because this will go to 4 over negative 2, which is negative 2. All right. Now I'm going to clear that and move down so I have plenty of room for this. So we want to find the limit from the left side. That's what that little negative sign means. Remember, your left side, all right, so here's negative 2. All these variables here, all the way to negative infinity, is your left side. So normally the left side is always on top. In fact, I'm probably wasting our breath telling you this because you'll probably never find a case where the right is on top. But just in case, you can verify it. X is less than or equal to negative 2. Are all these values less than negative 2? Yes, they are. Are all of these values, so positive infinity, are they greater than 2? I mean negative 2? Yes, so we know that this is the left and this is the right. Now we're going to do it the same way we did earlier. You're just going to directly substitute in the negative 2 into the equation. So for number 8, you're going to have 2 times negative 2 minus 1. 2 times negative 2 is negative 4 minus 1 is negative 5. So the limit from the left is negative 5. Number 9, same thing, substitute the negative 2 in. So you have negative 3 times negative 2 squared plus 7. Negative 2 squared is 4. So this is negative 3 times 4 plus 7. Negative 3 times 4 is negative 12 plus 7 equals negative 5. Now, since we've done from the left and from the right already, this is since there's no plus or minus up here, this is simply from both sides at the same time. Well, all you have to do is look back at these two answers. If they are the same, which they are, your limit from both sides is whatever number this is. So since both of these are negative 5, our limit from both sides is negative 5. If these had been different, then this would be does not exist. All right. So if the limit from the left, limit from, I'm going to abbreviate, left different from right, then the limit from both sides at one time, the limit from both sides does not exist. All right, but in our case, they were the same, so that does exist. But tomorrow on the test, if you do this and you get a different answer for 8 and 9, 10 does not exist. If you get the same answer for 8 and 9, well, you've already done your work, so you just copy it straight down like we did. All right, so that also means that this function up here is also continuous at negative 2. All right, since the limit equals the same thing from both sides, that means that this function is also continuous at x equals negative 2. All right, there's your test review. Make sure you come tomorrow ready to pass your limits in test. Alright, it's not that hard. Pretty simple stuff, I think, especially the way I've explained it in this video and in the previous videos. So make sure you come tomorrow ready to pass your exam. Good luck.